All right, good afternoon. We are pleased to welcome you to the Washington Labs Academy webinar series. We hope you find the next hour or so useful and informative. We have developed our webinar series to deal with some of the technical and administrative issues that our customers face on a day-to-day basis. We recognize that engineering challenges can be complex, and we're always looking for ways to support the technology industry. Before we begin, a few housekeeping details. First, I hope everyone can see the title slide on their computer. A full screen view may be preferred. Your selection at your computer can be done by using the menu panel in the menu on your screen. Go to View and then select Full Screen. We estimate that the main bulk of the presentation will take approximately 1 hour. We welcome your questions. You can submit them to us via email questions@wll.com or to Tim Johnson, the presenter, who will be giving his email address at the end of the presentation. And now, I'd like to introduce our presenter. Tim Johnson is Senior Certification Engineer for American Certification Body and iNARTE Certified Engineer for both EMC and Wireless Device Certification Professional disciplines. Tim has been with ACB since November 2001. Tim has over 26 years in the testing and certification industry and has reviewed and certified thousands of devices across the technology spectrum. He has developed techniques and procedures for Energy Star, FCC, Industry Canada, Hong Kong, and Japan MIC requirements. He launched American Certification Bodies Operation in Taiwan and has overseen audit and surveillance programs and contribute to quality system for compliance with ISO Guide 65 for certification bodies. Tim has also served as member of the TCB Council Executive Board from 2007 to 2009 and TCB Council Education Committee member for several years thereafter. So, without further ado, let's turn our attention to the introduction of FCC and ISED equipment authorization with Tim Johnson.
Thank you, Kim. Can you hear me?
I can hear you clear.
Appreciate that. Give me a moment while we switch screens here.
Sure.
Just to confirm, can you see the screen now?
I sure can. Thank you for that.
All right. Thank you. Thank you for the introduction, Kim. I'd just like to say thank you to everyone who's able to make it today. Given the state of the world and things changing so much right now, and everybody having to adjust to different little bit of everything, really. Appreciate you taking time today to make it and be here for this presentation. I'd like to preface this presentation briefly by saying I do consider this going to be an introduction to the FCC and ISED authorizations. Much of what is in this presentation today is something that I started out in the lab in the 1990s as a technician, but much of the presentation here deals more with when you go beyond that point and dealing with the agencies and authorizations. And it took me really about 6 months to 6 months to a year to get a good grasp on several of the things and where things were found, what the requirements were, and where they were, and so forth. And much of that will be covered briefly in this presentation. If there is any questions or anything, we'll be free to address those either directly afterwards or by email. Please touch base with us as you feel you have any questions or would like anything to be discussed or talked about. In short, as we realize for North America, mostly U.S. and Canada is what we're focusing on today. Electronic devices have requirements that have to be met. Most of those requirements tend to be around EMC and radio. There's also safety requirements that are not necessarily regulated, so to speak, in many cases by the FCC, but maybe vendor requirements and whatnot. And there are medical requirements that we typically see for certain types of devices as well. The medical side of it does tend to regulate the RF exposure and transmitters for RF exposure, but the FCC is actually the one that oversees a lot of that and has to be done within their authorizations. What we've seen over the past, say, 20 years or 17 years is a big explosion when we're dealing with wireless devices, especially in the electronics industry. And we've gone from roughly certifications that the FCC sees of about a five-fold increase from 2000 to 2017. A lot of that is, of course, dealing with everybody's going to wireless products. Uh, the complexity of the products with multiple transmitters being able to communicate with different types of technologies is increasing. Also, new technologies in general, frequency allocations that are changing, and more bandwidth wanted by people, and all that. So all that factors in that we're seeing a lot bigger explosion of devices out there, and the number of type of certifications that the FCC, Canada, and others have to deal with has been dramatically increasing. It used to be the FCC did 100% of the authorizations back in the 90s, and then over the early 2000s to 2010 period, TCBs were coming into play and starting to handle a majority of that. There were certain things they couldn't do for a while, but at this point in time, as of a couple of years ago, the FCC is actually no longer doing the certifications themselves. They're done 100% by what we call TCBs. And ISED, though, still does both direct certifications, but the majority of it is still done through what they call CBs, not TCBs, but very similar type of companies. Many companies do both and whatnot. So just a quick overview of the FCC and what their role is. They typically, they're here to regulate the private sector and make sure that there's non-interference for certain types of services and licensed services that are protected, but all in the public interest in short. They tend to also have, if you see here, primarily commission establishes technical regulations and for transmitters and other equipment to minimize the potential for interference in radio services. So in short, the idea is to protect the public interest there. They also have an authorization program, and overall that helps to the equipment to reach the market and comply with the technical requirements. The FCC themselves are actually broken into various offices and bureaus with different types of functions, and the majority of the authorization side of it for equipment is something we're going to be dealing with today. Most of that is done through the Office of Engineering and Technology branch. There are other branches that deal with things such as the actual licensing of transmitters and wireline devices, cable TV and media and homeland security and other things like that, but that's outside of our direct interest today. So the OET themselves, their mission is to manage the spectrum and ensure that RF devices do not cause interference. And they have an EAS system, which is under probably a redesign at this point in time, that more or less is to facilitate the management of RF equipment to prevent interference. And that is a system that's there for all the certified devices that go through the certification authorizations. Not every device does that, and we'll get a little bit more into that as we get into the presentation. But in short, the system is undergoing a redesign and expected to be released actually earlier this year, but it's kind of been postponed, and we'll see effects of that over the next year or two, most likely. ISED in Canada, the Innovation, Science and Economic Development Canada, is the division that deals with Canadians in all areas of the economy to improve conditions regarding investment, innovation, trade, and competition. It's sort of like the FCC. They have different offices and branches with different functions. But in short, for the authorizations that we deal with, they're known as the Certification and Engineering Bureau of ISED. And these are links that you can go to and to see the different functions, of course, and to see this particular office. Now, Kim, I didn't ask you up front, but is this presentation going to be available to everybody afterwards?
Yes, Tim. I will make sure I give everybody a copy of this.
That way they can take the links, and if they desire, they can go do some more investigations. When we're dealing with especially wireless devices, authorizations for North America, both the agencies for FCC and IC for Canada and the U.S., there are some differences between licensed and unlicensed services, requirements, and things like that. Excuse me. But in short, let's just look at the definitions of them. Licensed devices are protected services. They're usually guaranteed to be an interference-free type of spectrum, usually that somebody has paid for, gone through a bidding process or whatnot, and they tend to operate important services in many cases that we want to be interference-free for a variety of reasons. Unlicensed devices are more the typical devices you're going to buy off the shelf as a consumer. Those are unprotected and must be able to accept interference received. They're not guaranteed any sort of protection such as a licensed device would be. Now, just to give some examples real quick, unlicensed devices that you typically would be off the shelf would be like your Bluetooth, your cordless phones, your Wi-Fi, your remotes, UWB devices, spread spectrum, which covers a variety of both WLAN and other devices, and uni devices. The key here, I guess, is for those tend to fall under something we call Part 15, but most of those are unprotected, again, as we were saying a few minutes ago. But they may not cause interference to the licensed services, and they must accept any interference received. Licensed devices for the protected side of things tend to be more of your land mobile radios. A lot of those are your security people would typically have stuff like that. Cellular telephones is a blanket license under the operators. Broadcast transmitters, your AM, FM, TV, and such. Business radios, weather radars, aeronautical stuff. There's all sorts of things that fall under this that are considered protected and whatnot. For a lot of these types of devices, they all fall under what's called Title 47 of the Federal Regulations, Code of Federal Regulations. There are several, I'm not sure exactly how many offhand, but 47 is the side that has the FCC authorizations and where they come into play. There's a whole bunch of volumes here. There's a whole bunch of parts that fall under Title 47, and we'll get into some of this a little bit next. But in short, licensed, unlicensed, and all the regulations for authorizations for equipment that fall under the FCC's purview fall under these different rule parts. Now, just to give a summary of some of these quickly, Part 2 deals with, these are all again under Title 47. Part 2 deals with general requirements. That's where you have some of your procedures, your requirements for the applicants, the type of documents that need to be submitted, the general requirements for tests and things like that. It doesn't deal with any particular design requirements or limits. Those tend to all fall under the specific rule parts that a radio or a device might fall under. For instance, experimental radios, radio frequency devices that are unlicensed, digital devices even would fall under Part 15. ISM equipment, Part 20, commercial mobile radio services, 22 and 24, which tends to be a lot of the cellular type of stuff. Satellite communications, wireless devices, Part 27 is also something that we're seeing in a lot of cell phones. Part 30 is fairly new, but it's where we're starting to get into some of the 5G usage is starting to fall under there. Telecom service, which tends to be wireline. We don't see much of that these days, but it still exists. Broadcast services under 73 and 74 for TV and FM and radio. Maritime aviation, private land mobile radio, personal radio service. These are all different sections of the rules where radios and wireless devices can tend to fall. And each one of these different rule parts is where you're going to typically look for the type of authorizations required, the limits, design requirements, RF limits, and such. So if you were interested in going and looking at some of the rules, if you're not aware of them already, there's two different links that we have here that you can look at your leisure at a later time. Okay, for Canada, the requirements are broken up a little bit differently. There's an RSP 100, which is your general certification requirements. And again, this is for certification authorizations. There are some of the standards that fall under, such as the ICES standards, that fall under something a little bit different. But the RSS Gen, there's an RSS Gen that is general overall requirements for all types of wireless devices. Then there's general interference causing standards, which tend to be non-transmitters in most cases. There's unintentional emissions, and I'm trying to think offhand, lighting devices and some others that fall under that. There is also I didn't put it up here, there is also an ICES-Gen that goes along with that if you're interested in not dealing with radios and equipment that requires authorizations. Equipment that does require authorizations under the RSS is broken typically into a 100 series and a 200 series. The way Canada has done that is they put all their licensed transmitters under the 100 series and all the unlicensed transmitters under the 200 series. One of the more common ones that we see today for both FCC and IC is going to be your Wi-Fi type devices, Bluetooth, and most of those fall under what's known as Part 15 247. And luckily enough, Canada chose to use a very similar numbering scheme, so it's RSS-247. It doesn't always work that way with the numbering system. It just happens to be, in that case, it works well. There's also terminal equipment, your wireline type devices, all CS-03. There is some broadcasting type standards that we see very little of, at least myself, that falls under some BET standards. Many of these different standards, we use the word harmonized in quotes here because they're not technically, I guess, harmonized, but obviously if you compare the standards side by side, there's been a lot of work done in the background in many cases to make the requirements equivalent or very close to equivalent or similar. Now that's not 100% though. There are some types of devices which clearly between FCC and Canada are different, but a lot of your common ones and your unlicensed stuff, the majority of those are nearly identical for all practical purposes. And here's some links I provided for you to look at later if you're interested in looking at the general certification requirements or any of the particular RSSs themselves or the digital device type standards here or the wireline standards. When we're dealing with authorizations for FCC in Canada, a big part of it is the EMC, and that's what most of the regulations have been up to on the previous slides, side of it, the radio and EMC side of things. However, what's become a big thing since the early 2000s is RF exposure. In fact, in some cases, it's almost more technically difficult and complex than the EMC and radio side of things. There's a variety of standards that fall under RF exposure and that you have to look to. There's the AMC documents. This used to be an older OET document, which is technically phased out at this point in time. IEEE 1528, and then the FCC does have rule parts that mention the requirements and having to meet these requirements under Part 1, Part 2, and depending whether you're mobile or portable, which have the definitions here for mobile and portable are a little bit different than what we may logically think, but they're usually based on a distance to the user is how that's really defined. And then some of the rule parts directly themselves, such as our 15247 will specifically say you need to meet RF exposure as well, or it's more of a reminder, I think, because what the FCC and Canada will both say is regardless what the standards say is you always must be in compliance with RF exposure. So many times a lot of people are confused when they go to do a certification or authorization under a particular rule part and it doesn't say anything about RF exposure, so they don't address it, and then we look at it during an authorization process and then say we need some more information. And in short, with it's really incredibly low power, that's something that just kind of might be overlooked. But when we're dealing with general RF exposure for something that's higher power, because the FCC requires you to be in compliance, or Canada in compliance in general, we have to go take a look at it a little bit deeper sometimes. RSS 102 is for Canada, where you're going to see the general overview for the requirements there. And then, of course, now Canada is pushing a little bit the envelope beyond what the FCC is dealing with RF exposure and doing SPR 002, which is nerve stimulation requirements, which deals really with below 10 megahertz, very low frequency type of RF exposure requirements. When it comes to equipment authorizations, the next thing we wanted to talk about a little bit is the type of authorizations that are offered or need to be done with the agencies. For the FCC, there used to be a lot more than we see here. When I started in this business in the 1990s, there was 4 or 5 different types of authorizations that basically had to be done. And then even under these, there's some subdivisions and things that occur. But in short, today, now as it stands, we deal with an SDOC process, Supplier's Declaration of Conformity, or a certification process. There are some little differences between them, but the SDOC typically covers most digital device type devices that are non-transmitters, receivers, other unintentional radiators, or TV interface devices. There's some ISM equipment. There's some other things that fall under that as well. To do this, the test lab does not necessarily need to be accredited. That may cause some confusion when somebody looks at DOC and accreditation say, don't you have to be accredited? It actually used to be, before the SDOC came out, that it was a DOC process, and it did actually require accreditation. But in the past couple of years, the FCC has switched the authorization requirements, and it's kind of almost flipped in some cases. What didn't have to be done at a particular accredited lab does have to be now, and vice versa in many cases. So if you haven't looked at this for a few years, it may look a little backwards to you. The certification requirements do require you to go to an accredited test lab now, and not only does the lab have to be accredited, it must also be recognized by the FCC, which more or less means that the FCC has been put on record with the FCC, and they have gone through their accreditation and compared it to their scope and everything, and put that up there for listing as well. It takes place of the old site listing requirements that many of us may have seen years ago. But in short, when a lab does certification work, they have to be, one, accredited, they have to be, two, recognized by the FCC. But it may not be cited up here, but also the scope of what they're actually doing has to fall under that recognition by the FCC. So just because they're accredited, but they may not be recognized for, let's say, Part 90, they can't suddenly go do Part 90 and still get it authorized through the FCC. They have to make sure it's on their scope. So certification tends to be for most types of transmitters. There are a few oddities throughout the rules where you may not need actually to do a certification, but in general, most wireless devices are going to have to be certified in most cases. The certification process also can detail anything that was covered up here by the SDOC, and I'll show that on a table coming up here in a slide or two. You actually have an option in some cases of which authorization to do, but in other cases the rules mandate using one or the other or whatnot. So I'll show a little bit of that and actually some examples coming up here next. I did want to point out some little differences, I guess, between the SDOC and certification. That may not be obvious at first glance, but it's excuse me, other than the accreditation requirements, certification process does go a little bit further than an SDOC process, where it's actually submitted to an agency for review. TCBs is what we call them again, and they have to go through a review process. Once it passes the review process and everything's been completed and finalized, they will actually go forth and put it on the FCC site, and it will be viewable publicly, or at least hopefully a majority of it will be viewable publicly. There are certain documents that can be held confidential, though. And that's something during the SDOC process is a little bit different, where the manufacturer just keeps certain things on record. Should the FCC or anybody ever have a question or ask, or there's concerns that come up about it. So there is, but more or less, more oversight. It goes through, for the certification process, has to go through the agencies, through TCB review and then eventually to the agencies, whereas the SDOC is not necessarily going that far. There are also some differences in labeling and users' manuals. They're kind of minor, but there are some labeling differences, such as a certification has to have an identification number on it. The compliance statements are similar, but there are some differences between the two, and something you have to keep in mind which authorization you use will also affect that. And also to go on and say that sometimes you have to do both. Sometimes you have to do both an SDOC and certification, or choose to do an SDOC for certain parts of your authorizations and a certification for the rest. So in short, I wanted to provide some examples real quick in the rules where these authorization processes can be seen and kind of define what you have to do. But just to give some examples where you have to apply multiple types of authorizations really quick, is you may have two transmitters subject to different rule parts. For instance, your cell phone has a cellular transmitter that's probably subject to Part 22, 24, 7, 27, 90, or something like that. But then you may have a Wi-Fi in it as well. So that's actually subjected to 15247. You also have receivers that are associated with these transmitters, and depending on the receivers, if they fall within the bands of 30 to 960 megahertz, they're actually regulated by Part 15, for instance. You also may have non-transmitting devices, such as your cell phone in an idle state is a MP3 player or a game playing device. In short, you have to look at your device, look at everything that it's subjected to, and if you have multiple types of authorizations, you have to apply them all appropriately, of course. So it's not like you just pick the most worst case, or you pick one or whatnot. Really, the bottom line is you're subjected to them all. In the rules themselves, here's some of the examples where you can see what type of certification or DOC or you have to do for FCC. For a Part 15 device, again, this is unlicensed. Part 15B, the 100 series, is actually for non-intentional radiators. As you see here, you have like TV receivers, FM receivers, some various receivers, TV interface devices, some other things, Class B computers, in general, Class A, Class B devices and peripherals, and all other devices that would be subject to digital device requirements. And here it actually gives you a choice of using an SDOC or certification. So, of course, depending on which route you take, may have different labeling requirements, and of course will affect whether you're going to a TCB or keeping it on record and things like that, and whatnot. So different people for marketing reasons sometimes will pick one or the other. Some they choose just to have a better sense. They go to a certification route, which is a little bit more complicated, just to have a better good feeling about the device because they're new to doing these processes, like a newer company that's putting something on the market. But in short, the idea is certain sections of the rules you can choose. But then in other cases, such as a scanning receiver, it must be certified, for instance. So this is just one of those cases where you can go and look for 15B and what you need to look. Other parts of 15 deal with unlicensed transmitters. So just as another example, the 200 series covers a lot of different transmitters like the Wi-Fi, Bluetooth, RFID devices, your remote controls for your garages, and things like that. Usually will fall under 15 subpart C. And here, if you read through this paragraph, you'll notice that they talk about here they must be certified. So this is an example where sometimes you have to do a little bit of digging in the rules to find out what type of authorization will apply. A general rule of thumb, I think, is that most transmitters are going to require certification. There are some cases, even for 15C, where they do not need to be certified. There is a subparagraph that talks about it right here above, for instance, for certain frequency bands and at least 40 dB below the limits. Doesn't happen often and doesn't apply to most devices, but there are some other possibilities in some cases. And of course, in this case, it would be subject to the SDOC process, as we see. Part 95, a different rule part where there are some different types of devices that fall under that. There's some medical type devices. There's some remote control type devices for the higher power remote controls from years ago that we're used to, the toy planes and things like that. But this one also mentions, of course, if you do some digging and where it's found, transmitters require certification. Part 101 is a different example. And here they actually try to push you for a lot of these to go to a SDOC process, but then they actually give you the option, again, similar to what we saw back in 15.101, how certification for an individual transmitter may also be requested. So there is the case where you can kind of do either or, but they kind of are pushing you to use the SDOC process. In short, once you kind of know what section of the rules you're falling under, you can kind of look for your types of requirements as well as your authorization process. Well, now, since we talked about FCC, we'll move over to IC for a little bit. They have, in short, they have very similar technical limits to the FCC. As I mentioned earlier, a lot of the requirements are quote-unquote harmonized to a degree. But they also have an SDOC type of process for Category 2 radio equipment. Now, a category of equipment, if you go into one of the standards, I believe I have this on another slide coming up, it'll actually dictate a little bit about what a Category 1 and Category 2 type of equipment are. But in short, for digital devices which fall under the ICES standards, or for certain Category 2 transmitters, they do allow an SDOC type of process. This is actually something that since I actually work for TCB myself, so I deal more with the certification side of things. But this is kind of a term for Canada that's fairly new, and if you go look at the ICES, the new versions of the ICES-003 and the new RSS 310, they do mention SDOC in there, and more or less they even bring up the FCC that's trying to bring it more in line with the FCC requirements, I think, or to a degree, but there are some finite differences still. But then they also have certification requirements similar to the FCC, but in this case, use it what they call a CB, not a TCB, but many cases that's the same company or organization that's doing that work. But you can go directly to the Engineering Certification Bureau of Canada as well. I don't think they do that many these days, but it is also a possibility. IC, very similar to the FCC, does require now, as of the past 2 years or so, a lab to be accredited and also recognized to the particular RSs that are being tested and certified to. So, where some of this can be found if you're interested, and this is the category 1 and 2 as mentioned earlier. You can go look at RSS Gen and look for some of the definitions. But in short, the category 1 devices, they do require a TAC, which more or less means it has to go through a certification process and be issued a certificate by the CB. Now, despite the fact you might get a certificate from a CB in this process, really for Canada, the legal weight of when it's certified is when it actually finally shows up here on their REL. So the certificate, in more or less, is really just more kind of documentation that's being done, but that's not really your legal basis for selling. It's still when it actually hits the REL and is published. And you'll notice it even says it here, so nobody should import, distribute, lease, offer for sale, of course, until it's listed on the REL. Category 2 equipment are exempt from certification in this case, and really you kind of have to go look, I think, a little bit at the RSS 310, which covers Category 2 equipment, to see the type of equipment it covers, but it tends to be very low power, very similar to the FCC, where in certain things, I showed you a few slides back. I'll just scroll back here, maybe here. Similar to this right here is kind of what's going on in Canada, where a lot of those are put under 310. So, all right, moving a little bit into the rules themselves, other than the authorizations. This is part 2 of the rules is for FCC is where it covers the general regulations and filing procedures, general requirements of applicants, and so forth. There's over 20 different rule parts that can be applied, as we saw earlier, like Part 15, Part 20, 24, and so forth. But the basis for this is kind of a general understanding for what's required for the types of tests, the type of documents required for, depending on the authorization used, and things like that. The rule parts themselves are developed by different groups, usually through a public process, usually in conjunction with industry, of course, and allow for different operations in various frequency bands across the spectrum. Each rule part may have unique requirements. They may be, for instance, something required that's never required for other types of devices. It could be a design requirement, it could be a particular test, could be a limit, it could be specific documentation. You just have to refer to particular rules where your device is falling and make it, of course, for the requirements themselves. But looking at Part 2, which is 2-1046 to 2-1055, is more or less the basic minimum requirements of tests that the FCC is expecting for most types of devices. For licensed devices, they all apply. For unlicensed devices, there are some cases where certain things can be seen without having to apply them, of course. But for instance, the data required or the types of tests, for example, Part 90 device, Part 2 specifies frequency stability versus voltage from -30 to +50, whereas the Part 90 itself specifies the limits that are applied. So the general requirement that it has to be done is typically in Part 2. The limit, more or less, that's applied, or what it must meet, is typically found in the particular rule parts themselves. So here's a list of some of the different tests that are required for licensed devices. It says for all devices, but that's all licensed devices. Some of them may be omitted in certain cases for unlicensed. But in general, these are required regardless for a licensed device, even if there's not a limit given in the rule part for that device. So some rule parts actually don't have a temperature stability limit. And in that case, they still have to produce a test and include it as part of the filing because it's required in Part 2 in short. The RSS standards themselves, to see where some of this type of thing comes out, just for IC is going to be looking at RSS Gen for your general requirements. And as I mentioned earlier, there's the licensed and unlicensed for the 100, 200 series. There's also a new requirement I haven't mentioned for HAC, which deals with hearing aid compatibility and RF exposure. But they have roughly 50 titles for the RSSs that different transmitters can fall under, similar to the 20 so rule parts that the FCC has. Bear with me for a second here. what I was trying to get at here, this slide here is really mentioning that the rule parts themselves generally provide the limits and the specifications, technical requirements, procedures, general frameworks for the authorizations and things like that. However, they do dictate sometimes the test methods that need to be applied, but they don't put the methods themselves into the standards. They're usually there by reference. The FCC normally, in Canada as well, have relied on industry standards that need to be applied in many cases. However, we do have to caution you that you can't just go straight and use the methods themselves all the time. There are certain cases where the FCC, the rules themselves may specify a particular bandwidth that the measurement procedures may differ from when you read those. So the idea is they do take precedence in the rules. If the rules have something that's stipulated, it does take precedence over the measurement procedure themselves, even when the measurement procedure is referenced. There's also information that they publish in KDBs and notice and trainings and things that change over time. And you kind of have to gain a knowledge of all this together just to make sure for certain types of devices that everything is being applied that needs to be and measured to the way it needs to be done. So it gets fairly complicated in short. For Part 15, just to give you some examples of the references, 1531 does provide various measurement standards that apply to Part 15 devices. The majority of those fall under an ANSI standard, which I'll show, I think, here in the next page or so, C634 or C6310, but there are some others that, like PCS transmitters and things that are also listed there. Part 2.947 does provide some overall measurement procedure info for licensed devices, but they really don't provide any direct references offhand. What is very interesting is if you go to this page here from the FCC, this is where they publish a lot of their by references and what should be applied for various types of devices. But it includes 6 different standards for EMC and radio. There's 4 for licensed operation, and then 10 for RF exposure. And a lot of those are KDBs or other types of standards that you need to get familiar with from the actual procedural for the measurements that you might apply. These are the common ones, or some of the most common ones that we see today applied. It probably cover, gosh, if I had to throw it out there, somewhere on the order of 80% plus probably of most devices. But C634 is what we apply now for digital devices or non-transmitting devices. This used to be, years ago, if you haven't seen this type of or done authorization work in many years, going back 10 or 20 years ago, even some of the unlicensed transmitters would apply this. But today, now, this has really become a standard that's applied only for the non-transmitting digital device types of cases under Part 15. Then we have C6310, which is unlicensed wireless transmitters. And then for the licensed side of things, there's C6326. There's also a TIA 603 standard that's still referenced by the FCC, but generally I think the goal originally was when 26 came out was to kind of replace it, but there are some cases I think where 603 still makes some more sense, usually for your very narrow band transmitters, which we're seeing less and less of, it seems, these days anyway, with everybody wanting more throughput and bandwidth. The FCC rules themselves sometimes dictate some additions and things that have to be taken in consideration, and of course the KDBs that I was just mentioning. You can subscribe to the KDBs or go directly and do some searches on the KDBs as well. There's ways to do that on the FCC site. If anybody has any questions where to go do that, I'm not sure I put that in the presentation, but I can provide you where to go look at that later if you like. In Canada, for the measurement procedures and so forth, they too also use very similar or the same C6326 and C634 and C6310. Those are all stipulated in the rules for measurement procedures to follow, and this is where you can find it. Is of course the RSS Gen in Section 3.2. So what I want to do next is talk a little bit about the application process if you're actually using the certification process, because the DOC process is something that would typically be done between a laboratory that's doing your testing, and certain things are typically kept on record by the manufacturer or applicant or whatnot. But if you have to take the next step and go for a certification route for certain devices, That's what we're going to cover next, is some of the application requirements. First, just a reminder, of course, that for both agencies, more or less, that the lab needs to be accredited, first of all, and then also recognized by the agency for the particular tests that are being applied. So once you've got your testing done, then what you have to do is submit an entire package of documents. You're gathering together all the technical documents that are required and submitting those to a TCB. Many times the laboratories will offer that service for you and submit it directly to a TCB, but it's also something that the applicants can do themselves. There is a fairly, I'm not going to say steep learning curve, but what we've seen is people that try to tackle it on their own that are fairly new to the process. It tends to take quite a while, and I would recommend anybody that hasn't done the process, if they're starting to get into doing certification, is to let a laboratory probably handle it for you until you get an idea of what needs to be done. Hopefully the laboratory is providing you copies of most everything, if not everything that's being sent, including the forms and the letters and stuff that they may help contribute to, as well as the test reports. And it just helps streamline the process when you're learning it. What happens next, of course, is the TCB will review the entire package of documentation that's required. When they're satisfied that everything meets all the requirements, both from the minimum documents that are needed to the technical requirements and the measurements, they proceed to upload that to the FCC and post it on the FCC site. Then you get a grant of authorization, which is more or less a piece of paper that's publicly viewable as well if you go to the FCC site. That is your authorization to start marketing the device from that point. And here's some links. This is a link that you can go actually search out there all the active grants, pretty much that have ever been published. Of course, nothing's going to be published until it's completed the process of certification. The certifications themselves can be broken into a few different types of things. Usually, if you have a new device that's never been certified, you have a new certification that you're going to deal with. But there are cases where you've already certified the device and need to come back and make changes. So in short, that could be a Class 2 or Class 3 permissive change. There are also some change of identifications, which are done when somebody already has a certified device and another company wants to take responsibility or make some changes to it. They start out doing what's called a change of identification, which gets a copy of their filing from one certified FCC ID to another. So company B takes on the responsibility and gets something that's already authorized under their own number. But that does take approval from both parties, both the original party and the new party, to do that. And then, of course, during the certification process, or as part of it, there might be modular approvals. There might be limited modular approvals that apply. And those just create other types of complexities that have to be brought in and considered in the process. So the applications exhibits that are required for these different authorizations can be found under the FCC DOC process. There's these rule parts you can go to find some of the basics of the responsibilities of what needs to be kept on record by the supplier or the applicant, so to speak, as we call them, manufacturer. Also some labeling requirements or manual requirements that have to ship with the device. For certification work, Part 2, 1033 defines the minimum documents that are required to submit for certification. It is actually subdivided by licensed and unlicensed devices. There's a section B and C. They're very similar, and I'll go over those next year in a minute in short. But an application typically for certification would require, and these are kind of the minimum requirements, a Form 731 to be filled out, various cover letters giving authorizations to appropriate companies. There's confidentiality requirements and letters if you're requesting it, and most applications do. And also can be long-term or short-term. It can be 1 letter, 2 letters, depending how it's written. Of course, the test reports supporting compliance. There also is a need to look at a lot more documentation, such as the user's manual, photographs of the device, both internal, external, and test photos, the theory of operation of the device, block diagrams and schematics, which typically are considered confidential by most companies, of course. Artwork of the actual label. That doesn't have to be a final version, but at least a mocked-up version or a sample of what way it should look. Also, the location and positioning of the label on the device. There are some additional attestations that are sometimes needed. depending on the type of device. Professional installation or things like that could factor into needing those. And then some other examples would be software security descriptions that might be needed for certain parts of the rules that have additional requirements where you need to submit that type of documentation. But all this is typically required for both licensed and unlicensed devices for the most part. I think the only exception might be block diagrams, which I'll talk to you here next. But the licensed devices do have a few more additional items that need to be considered and included in their applications. There has to be more details on the transmitters, modulation techniques, response characteristics, and so forth. And also DC voltages and currents into the final amplifier stages. Tune-up procedures have to be provided. Many times today, this is not what it used to be. It's more of a simplified process and description, but if you have any questions on that, we can talk about that offline, so to speak. Block diagrams are not actually stipulated by licensed device requirements as part of the application process, but most people still include them because they may have a licensed and unlicensed combination. But also it does help to ease the overall review process because most of us that have been doing this for years, it gives us a general overall idea of certain things and as we're getting into an application. So we see that where most of the time people are including that anyway, but if for some reason somebody doesn't want to, that's one thing that we don't necessarily have to have for the licensed devices. ISED processes are very similar. In short, you have to have the accredited laboratories, of course, both recognized and accredited for the particular standards being applied. Again, you're going to gather your application together, submit it to a certification body or directly to Canada. Again, very similar. When either Canada or the certification body is done reviewing the application, they will submit the documentation to Canada, and it will be published on their website and issue a certificate typically to you. ISED then places those details on their REL, as they call it, the radio equipment list. However, in their public site of viewing these types of authorizations, they do not actually give you access to any of the exhibits. The FCC, for instance, most of the documents that are, or at least the ones that are non-confidential, are displayable and viewable to the public. But in Canada, unfortunately, that's not something that they have. And then, of course, you get your usually your certificate at the end, and it gets listed on the REL. So just a reminder, though, that even the certificate itself, it has no legal basis for Canada. It's that final listing on the REL that you have to look for. Canada has a few different equipment type authorizations to consider. There's your new certification, very similar to the FCC, but in their cases, sometimes they have more concern over the differences and the models themselves, or HVINs as they call them now. It used to be models was what was used in the old days. And if you have a series of models, we have to take into consideration at the labeling and listings, and that's called a family certification when you're dealing with more than a single listing. If you have multiple models, multiple HVINs that are being applied, we consider it a family certification. They also have permissive changes. They break it down, and though they have a Class 3 and a Class 4, depending whether it's just strictly software or if maybe it's integration into a host. They have multiple listings, which is very similar to the change of ID mentioned for the FCC process. And again, other complexities that can factor into this but are considered during this process is breaking it down into including a modular approval or limited modular approval in some cases. The exhibit types that are required for Canada can be found under RSP 100. That used to be they used to have a section in the back of the document, but the newest version actually just references a Form C, and it's actually a separate document that can be found at this link here. But in short, I think the idea is most of those documents for Canada are very similar, or the same documents, especially the technical documents. There are some additional cover letters, forms. The forms are different, of course. There are some additional cover letters, such as a Canadian rep letter, which is not required for FCC. Some ARF exposures, particular attestations that are needed for Canada. The FCC, you have to address ARF exposure for both agencies, but there are some additional forms and things that have to be included as well. I guess as a general policy, if you have an FCC application and you're doing IC as well, more or less most of the documentation is going to cross over with some additional work that needs to be done with some new forms and letters. Of course, your test report will have to reference both the testings done to RSS requirements for Canada and the FCC requirements for the rule parts and things like that in some way. But overall, the paperwork's very similar. And then this wouldn't really be complete without mentioning at least the KDB system, and this is where some of the guidance, policy decisions, and things that the FCC publishes for guidance in general can be found. You can do searches. There's many topics there and this is a very important link that most of us in the industry that we're using quite often, daily, usually for most of us. IC accepts guidance for some of these KDB publications and so forth, and here's a link you can go to if you're interested in that. Many times we actually go to Canada and ask things behind the scenes. They don't necessarily have a formal database that they publish like the FCC does. And of course, the KDB system is where the FCC is also pushing contact in general. It used to be we could call up an engineer and ask some questions. They would refer us to the KDB system. But in short, they really like everything just about in general. An inquiry, a question, even when we do for surveillance and audits and things, we're publishing it and pushing things through the KDB system in a variety of ways. But if you're looking for anything interpretation-wise, we commonly get questions from clients, and we usually forward them to a particular set of KDBs to go look at and review. Just keep an eye. I know I talked about a lot of different things here. The paperwork of an authorization that has to be included. We can go into a lot more detail on that. We can go into a lot of detail about modules and RF exposure. And those are topics that literally, for instance, RF exposure alone was a 2-day complete, 8 hours a day training at the FCC going back to the early 2000s. It's only gotten more complicated today, so it's hard to put this stuff into a very short presentation, an hour and whatnot. But we will be publishing more and have more topics down the line, and look forward to giving you more details and being able to help anybody that might need some background. And that's really it. Sorry I had to try to rush through it for the hour, but I think that's what I had to present. Hope you find it useful. Do we have any questions, I guess?
Yes, thank you, Tim, for a wonderful webinar presentation. I do see one question, and it is, what are the requirements for a host device? SDoc tests needed?
What are the requirements for a host device? SDoc requirement. Well, I think we'd have to find out, in short, a little bit more about the device and what it incorporates. But, if I just threw out some assumptions offhand, which was a very dangerous thing to do, of course, but if you're dealing with the host, it sounds like they're applying a transmitter module or a module being inserted into the host. What's very interesting is modules have had a lot of concern by the FCC and IC in recent years. And they've actually published a lot more guidance in the KDB system, both for the OEM that sells the module and also the integrator and their responsibilities. They have a separate document for each of them that they publish for guidance that I can funnel to anybody. I don't have the KDB off the top of my hand. I want to say it's 996369, but I'm not 100% on that. But there are particular guidance that can be provided through those for those that are inserting transmitters. If they're talking about a host in some other format, I would have to really discuss a device with them, I think, at this point to make sure we're on the same page.
Okay. Just real quick, I see a question of, can I please send the webinar to the attendees when it's done? Just so everyone knows, I usually try to send out the webinar 1 to 2 days after the live webinar. So you should be getting that shortly. I would say if you don't get a recording maybe by Tuesday of next week, you can go ahead and shoot an email to either the questions at www.com. Even Tim, and let him know, and he'll get to me, but I'll definitely get it to everybody who has registered.
Yep. Thank you, Kim.
You're welcome. I do see questions coming in. Do you send the presentation by mail? Again, that would be email that you had provided when you registered. Hopefully that answered a question. Beyond the FCC, are there any other regulatory requirements that an electronic device needs to meet before going on the U.S. market?
Well, as I mentioned earlier, there are safety and medical requirements that could come into play that are regulated by different agencies. Safety requirements are typically not per se regulated, but they could be a requirement of whoever's purchasing it. I've also seen in cases where certain types of devices over the years, the purchaser has very specific requirements above beyond anything that we're dealing with here, both design-wise, capability-wise, and other, just could cover any number of aspects. But yes, those are possibilities. What we're focusing on here, of course, today is mainly dealing with the regulatory authorizations to sell and what the FCC regulates or Canada ISED regulates. They don't get involved with the safety side of it other than RF exposure. RF exposure, the FCC will say they don't even deal with calling it safe or unsafe. They just deal with limits that have been specified elsewhere, and it's pulled into the approval process. So it is something we do have to look at, but again, not sure if that's really answering the question, but best I can do off the fly, I think.
Okay, I got a couple more questions if you don't mind.
We'll give it a shot.
Okay. What are the requirements for multiple transmissions simultaneously?
Okay, so if you have a device that has multiple transmitters, for instance, generally speaking, there is requirements for standalone. You have to meet each of them in a standalone condition, and then we need to look at them simultaneously if that exists. Now, it is possible for a transmitter to have two transmitters that do not transmit simultaneously. The software firmware governs whether they transmit together or not, and if something precludes them from testing, then we are not concerned with simultaneous. But if they are actually capable of simultaneous transmissions, then we are concerned with looking at that as part of the process generally. There is some guidance given, for instance, in the modular policies about what to test and not test. But again, it's guidance because when you put different types of transmitters together, unique things can happen. So there are different ways of looking at it and what tests need to be done or not done. But in short, the integrator is responsible for the device in a whole under all circumstances. So if you do have multiple transmitters tied together, then that's something that has to be considered. One thing that is confusing to a lot of people that I've seen is when you actually do tests for simultaneous transmissions, you may have different wool parts that you're dealing with. For instance, you may have a licensed transmitter that's much higher power and an unlicensed transmitter that's very low power put together in a single device. It's not right to have to subject the high power to low power limits, and the low power, it feels funny to apply a high power limit because it's subjected to very stringent limits. How do you address that? There has been a lot of confusion from people over the years for that, but in short, what the FCC allows you to do is you have to test them standalone. So each one has to meet its own limit standalone. Then once you combine them after that point, you actually take the least stringent limits because you can't make something go more stringent than it was before. But in short, you're looking at the combination at that point. So the combination is allowed to use least stringent limits, and in a case like a licensed and unlicensed, you would then test them together simultaneously and then look at the limits under the licensing requirements and make sure that those additional spurious or intermodulation that's occurring or whatever it might be are compliant with the least stringent limits.
All right. Next question. If I have a radio with Wi-Fi and LTE functionality, can I only get the approval for LTE only if I'm able to disable Wi-Fi with SW?
With the software, I think.
Okay,
It's
thank you.
if I radio with Wi-Fi and LTE functionality, can I only get the approval for LTE only if I'm able to disable the Wi-Fi and software? I think the answer to that depends on a couple things. One is if you are doing a original certification on its own to standalone, and you produce documentation and attestations and explain how that's done, then you might be able to do just the LTE only, yes. If you were dealing with a product that's already certified and doing some sort of permissive change to it, that gets a little bit more complicated because the original approval already includes both. In a case like that, for instance, I've had some cases where somebody has a device that has Wi-Fi and Bluetooth, and they're only going to use the Wi-Fi side of it. They're getting different grants of authorization for both. We actually have to, because of the original had both to start with, we have to go out and specifically we issue the grant for both. But on the second one that's not applicable anymore, we actually put a statement on there that says that this has been disabled in a particular host or a particular situation. So there are ways to kind of handle that and consider that. But I think the answer kind of depends on whether you're dealing with the full answer to the question will deal whether they're dealing with a full certification that's brand new, or if they're actually dealing with one where they're coming back and making changes to an existing approval. So.
Okay. Let's see. Does Part 15B testing for the digital section of wireless equipment include the frequencies, i.e., harmonics, of the wireless device?
The Part 15 side of it, if you were doing so let me see here. Let me see if I can find the question again. Okay, does 15B testing for the digital section of a wireless equipment include the frequencies of the wireless device? Usually the 15B testing is done with the transmitter in an idle state or receive state mode of operation. So usually your highest frequency that you're testing to, if that's what they're really concerned with here, would still be dependent possibly on the receiver or some other things that are existing in that device. There is a similar type of question I know that's been posed to the FCC, and if somebody wants to get in touch with me on that, I could probably produce that. I have to dig for it a little bit, but with the 15B side of things, some people try to test that with the transmitter on and say that it still covers the 15B side of things. And my experience in the lab, going back quite a ways, is it's sometimes that's the case, sometimes that's not the case. In short, it is possible, and it does seem to work a lot of the time if you were to do it that way. But I have actually seen cases where the digital device emissions passed with the transmitter on, and as soon as you turn the transmitter off and it's in idle state, suddenly the digital device emissions failed. So it's really hard to say, but they're asking if they should include the frequencies of the wireless device, and I think that depends a little bit on the receive side of things, being in a 30 to 960 band and some other things. But in short, the FCC has kind of included some of that, and I need to get that interpretation out to them if they want to look at it deeper.
All right, thank you. I'm going to.
Sorry.
That's okay. One more question.
Mm-hmm.
In the application for FCC and ISED, there is a limited modular approval. What does that mean?
Okay, limited modular approval versus modular approval. We'll hopefully have some presentations down the line that get in a lot more detail for this for you. But in short, a full modular approval is when every aspect of the various requirements are met, and you give it a full modular approval, and there's no conditions on how it's sold or used, in short. But for instance, there's shielding requirements. There is voltage regulation requirements and things like that. So if we were to have a situation where something like that does not apply, then it becomes what's called a limited modular approval. Limited means you've met a subset of the above requirements, but it also means in general that it's controlled on its use and sales, or only used internally to an organization's products. So I think more or less today, if you ask the FCC, this is what they're saying. And limited modular approval is limiting it to the applicant's use only, or the grantee's use only. So they have to control its use internally on their own products. I think I've seen some cases where maybe there's some sort of sales agreement and somebody else markets a device for them, but that starts to get into some gray areas depending on the situation. So I think the general understanding is limited means it hasn't met all of the requirements for full modular approval, and the grantee is limited in its use to only their devices.
All right. Well, thank you. If your questions were not answered, please feel free to send your questions to the email you see on your screen to Tim, the presenter, at tjohnson@acbcert.com, or you can even send it to us at questions@wll.com. Our thanks go to Tim Johnson for taking time out to enlighten us about the introduction of FCC and ISED equipment authorization. We have 2 webinars coming up in April. modern EMI receiver measurement concepts, and 5G millimeter wave spurious testing, which is scheduled for April 16th, and wireless coexistence on April 23rd. So be on the lookout for registration. On behalf of the Washington Labs Academy, I would like to thank Tim and thank you all for attending. And I will go ahead and now end the event. Please enjoy the rest of your day and stay safe. Thank you, everyone.
Thank you.